What's this? A demand paging, this question is asked in GATE 2007 in IT question paper, and the question is this, I'll read out and explain for you. A demand paging system takes 100 time units to service a page fault, which means the page fault, page service time or the page fault service time is 100 time units they are saying, and 300 time units to replace a dirty page. So in case if the page is dirty, they are saying that it will take 300 units. So what is that they are trying to say is, whenever there is a page fault, if the page is not dirty, the time taken is 100 units, and if the page is dirty, the time taken is 300 units. So why is this so? So what is the concept behind it is, let us say this is the main memory, okay, and now these are the frames, right, and say this is the page, this is the process. So even though the process is having many pages, it will generally be allocated some few frames in the main memory. So for the sake of generality here, let's say we have allocated only 3 frames for this process, which means this process can occupy only these 3 pages, these 3 frames, right? Then what happens is, at any point in time, only 3 pages of the process will be present in the main memory. In case if you want any new page, which is not already in these frames, then you need to replace one of them. That is called replacement. And when you try to replace one of them, you cannot directly overwrite on that in case if it is modified. So I told you that there are generally three types of sections in a process. So one section is code section means the program which you have written, that is the machine code. And the second section is data. So data means there will be global data, static data, and then the heap data. So entire data section is this one contains 2 sections. One is that global data or static data, and other is dynamic data. Dynamic data means a memory allocation and all, heap you can call it as. And the third one is stack, right? So whenever you have code segment, we generally don't modify the code segment. So whenever you load any page of code segment, the advantage with code segment is, we will just read from the code segment and we never write anything onto the code. Why? Because we don't change the code once it has been written. While running, we don't change it, right? It is not allowed. Therefore, so if one of the pages is code, let us say, another page is data, another page is stack. Let us say this one page is from the code segment and one page is from data segment, and other page is from stack segment which got loaded. Let us say that is the scenario now. And now suddenly I have to get one more page, which is, let us say, some page. So this is page number 1 and this is page number 2 and page number 3, which are present in our main memory. And now I want some page number 4, right? Then what happens is, if you choose to replace page number 3, then you can directly overwrite on page number 3, because there is no way you have ever modified the code section once it has been loaded. But then if P2 is chosen for replacement, the chances are that the data page would have been erased or overwritten. So you cannot directly load a page on top of it in case if it is dirty. Dirty means after loading it earlier, you might have modified it, right? So in that case, what you should do is, you should write it back first. So let us say this one belongs to this page. This is 0, 1, 2. So in case if you have modified this page and now you are trying to replace it, then first you write it back and then load the new one. So in case if you want to replace this, let us say this is here, you can directly overwrite on that. You need not write it back because we have never modified it. Therefore, operating system will know whether a process has modified a page or not by using the bit called as dirty bit. So dirty bit will say whether a page is replaced or not, modified or not. In case if a page is dirty, which means it has been modified, then before you replace it, you write it back. So page fault time is going to take more time in case of page fault, in case if there is a dirty bit, which means if the page which is chosen by you in order to get replaced is dirty, then the page fault time is going to increase, right? So that is what they are saying. In case if the page is not dirty, time taken is 100 units, In case if the page is dirty, then the time taken is 300 time units, right? So they didn't actually give you the page fault service time directly. They have given it indirectly in two ways. So it is going to be either 100 or 300 depending on whether there is a dirty bit or not. That is the first thing. And the second thing is memory access time is one time unit. So in case everything is fine, if you can directly find what you want in the memory at the first go, then the time taken will be one time unit, right? And if it is not present in the first go, then you might have to go for a page fault, which is going to take some extra time, and then again you have to access it, right? Then the probability of page fault is P. So they are saying that there is a page fault with a probability P. In case of page fault, the probability of page being dirty is also P. So which means the probability for a page to be dirty is P, as well as probability for the page fault is also P. Now it is observed that the average access time is 3 time units. Then they are saying that whatever this P is, we are finally getting the average access time as 3 time units. Then what is the value of P? They are talking about what should be the value of P. Here P represents two things. One is the probability that there is a page fault, and second is once there is a page fault, the probability that the page chosen to be replaced is dirty. See here our assumption is that we don't have a free frame. In case we have a free frame to get the new page, then there is no need of thinking about dirty, right? But then in most of the cases what happens is we will not have enough number of frames, therefore we have to continuously replace what is existing. In that case you have to worry about the dirty bits also, right? So fine. Anyway, let's do it step by step. First thing is they didn't give you the page service time. So page fault time or page service time they didn't give you directly. So they are saying that it is, if there is no dirty bit set, then the time taken is 100 units, and if there is dirty bit set, then the time taken is 300 units. Therefore page fault time is if there is no dirty bit set. So the probability for the dirty bit setting is that a page is being dirty is P. Therefore no dirty is 1 minus P, right? In this case it is 100 units. In case if the bit is dirty, right, if the page is dirty, then in this case it is 300 units. Therefore this is the page fault time or page fault service time, right? And once you have observed this, once you derive this page fault time, maybe you can even simplify it. It is how much? 100 plus 200p, right? Okay, so this is the page fault service time. And next thing is once you have found out the page fault service time, and memory access time is also given. So memory access time is 1 unit, right? This is also given, and this is what I got from this information, right? And now average or effective memory access time in case of page fault is, if there is no page fault, I am going to take 1 unit, isn't it? We know the formula. So what is it? Effective memory access time is M plus in the page fault rate into page fault time. So how much is this? M is 1 unit plus what is page fault? Page fault rate is P, that is what they have given, and the page fault time is 100 plus 200p. Now they are saying that the effective memory access time is found out to be 3 units, which means this entire thing happened to be 3 units. Then we have to solve it and find the value of P. Now what we get is 200p square plus 100p minus 2 equal to 0. So this is what we get. This is the equation we get. Now we have to solve this equation in order to get the value of P. So in order to solve this, you can use that formula, minus b plus or minus square root of b square minus 4ac by 2a. So you can get the value of P like this, minus b plus or minus square root of b square minus 4ac, b square minus 4a and c is minus 2 divided by 2a, right? Now if you solve it, you are going to get an answer of 0.0194. This is the answer, but here the option is not given. Option is given as 0.194, right? I mean the option is not there in this question, right? So I think they might have missed out 0.0 here. So all the options have to be added 0, and without that it is not possible. I'll tell you why this answer. No, why this is this answer is right. You can check it, and maybe this one you might have to pick because there is no other option, and you don't pick anything in that case. If no answer is given, don't pick anything, don't guess it. If they have given it wrong, they are going to add marks to everyone. So you don't pick for any option. Answer is 0.194, 0.0194. So, but then in many of the books they are given that the answer is 0.194. I'll tell you why this is wrong. Why this option of 0.194 is wrong. The reason is, if you say that the page fault rate is 0.19, what is P? P is the page fault rate. Let's assume the best case. What is the best case? Let's assume that there is no dirty bit at all. Then I want to find out the average memory access time, right? Then effective memory access time, in case if we assume that 0.194, this is the least one, isn't it? So if this is the least one, if this cannot be answered, nothing else can be answered, right? Why? They are saying that effective memory access time has to be 3 units. So what is effective memory access time? Equal to memory access time plus page fault rate into page service time, right? So even if you assume that there is no dirty bit setting at all in the best case, then also what we get is, now if I substitute it, what is memory access time? 1 unit, plus if I go for this 0.194, and what is the page service time? In the best case, the page service time is 100. In worst case, the page service time is going to go till 300, right? I'm taking the best case, so which means the least page solution and the least page fault rate. I'm taking the least page service time and I'm taking the least page fault rate given in the options, and still using this, you might get the answer as 1 plus 19.4, which is nothing but 20.4, right? It is not equal to 3. So even with the lowest answer possible, lowest page fault, you will never get a average effective memory access time as 3 units. They are saying that the effective memory access time has to be 3 units, but with this option, the effective time access will never come to 3 units, right? It is not even close. So if it has to be 3 units, then the probability has to be 0.0194. None of these options will suit. You can take each of them. Okay, one more thing, you need not do the question like this. You could have even taken the options and you could have verified. So you can take each option and see what is it giving as the effective memory access time. But then even if you do that, none of the options will give you 3 time units as the effective access time. Only answer is 0.0194. Got it?